The ground shook first, then the sky turned gray. On the Kamchatka Peninsula in Russia's far east, one of the most restless volcanoes on the entire planet has exploded again. And this time, the ash column reached approximately 11 kilometers above sea level, with official forecasters warning it could climb even higher, possibly to 12 kilometers before the activity subsides. Aviation corridors across the North Pacific have been disrupted. Monitoring agencies from Tokyo to Moscow are tracking every seismic tremor in real time. And in the small town of Kluchi, roughly 50 kilometers from the summit, around 5,000 people are watching the sky turn the color of ash. This is Sheveluch. And if you have never heard of it, that is exactly the problem. Sheveluch is not a volcano that erupts once in a generation and then goes quiet. It is a volcano that has been in a state of near continuous activity since 1999. It does not wait. It does not rest. And the event that unfolded at the end of March 2026 is a reminder, sharp and undeniable, that the most dangerous geological systems on Earth are not the ones that surprise us. They are the ones we have learned to ignore. But that is only part of the story. Deep within the research bulletins issued by KVERT, the Kamchatka Volcanic Eruption Response Team operated by Russia's Institute of Volcanology and Seismology, the data from this eruption began arriving in the early hours of March 31st, 2026. The local time was approximately 6 in the morning. By that point, the eruption had already been active for hours, with the official UTC timestamp placing the onset at around 10 in the evening on March 30th. What the monitoring systems captured was not a gentle venting of steam or a slow lava flow creeping down a hillside. What they captured was an explosive, extrusive eruption. Ash and pyroclastic material ejected with enough force to push debris up through 11 kilometers of atmosphere, slicing through commercial flight corridors used by aircraft crossing the Pacific between Asia and North America. The Covert Bulletin listed the aviation color code at orange, the second highest level on a 4-stage warning scale. That classification is not issued casually. It signals that ash is actively reaching altitudes used by aircraft, and that pilots and air traffic controllers must actively reroute or take precautionary action. The Tokyo Volcanic Ash Advisory Center, which tracks airborne volcanic material across a broad area of the Pacific and Asian region, confirmed the plume was drifting east-southeast at altitudes between 10 and 15 kilometers, directly into the space where trans-Pacific flight paths operate. On the slopes of Sheveluch itself, pyroclastic flows, those fast-moving rivers of superheated gas, ash, and volcanic debris that move faster than most vehicles and incinerate everything in their path, had swept across between 5 and 7 square kilometers of the volcano's uninhabited lower flanks. Monitoring equipment at higher elevations sustained minor damage, and the snowfields blanketing the upper mountain, which had already been stained gray during a February 23rd ash event, were now receiving a fresh layer of dark volcanic particulate. Yet what comes next could be even worse. To understand why this eruption matters beyond the immediate spectacle, it is necessary to understand what Sheveluch actually is, not just as an active volcano, but as a geological structure. The massif itself is ancient. The older summit, known as Starry Sheveluch, is estimated to be approximately 65,000 years old. It sits inside a caldera, 9 kilometers wide, a scar left by a catastrophic collapse sometime in the late Pleistocene. That caldera is breached to the south, meaning the southern wall failed at some point in the geological past, creating a natural pathway for material to escape. Inside that ancient caldera, a younger and far more active structure has been growing. This is Molodoi Sheveluch. Young Sheveluch, a lava dome complex that has been building for decades, fed by andesitic magma rising from depth. The entire volcanic massif has a total volume estimated at 1,300 cubic kilometers. To place that in context, that is a mountain of solidified volcanic material vast enough to bury entire regions. And the lava dome at its core is not stable. It grows, it cracks, it collapses, and when it collapses, the result is explosive. Andesitic volcanoes like Sheveluch behave very differently from the fluid, flowing eruptions associated with Hawaiian or Icelandic systems. Andesitic magma is thick and gas-rich. As it rises, the gases dissolved within it cannot escape gradually. Instead, they build pressure inside the dome like a sealed pressure cooker. When the dome's outer shell weakens, through gravitational stress, internal gas pressure, or seismic shaking, the result is sudden, violent, and difficult to predict with precision. The dome does not just crack, it explodes outward, sending columns of ash, rock, and gas kilometers into the atmosphere within minutes. This is the mechanism that drove the March 2026 eruption, and the seismic record leading up to it provides critical context. Just 3 weeks earlier, on March 6th, a magnitude 6.4 earthquake struck approximately 143 kilometers south of Petropavlovsk-Kamchatsky, the regional capital located roughly 440 kilometers south of Sheveluch. Kamchatka sits at the convergence of the Pacific Plate and the Okhotsk Plate, or at one of the most seismically active subduction zones anywhere on Earth. When the plates shift, the stress propagates through the volcanic plumbing systems embedded within the crust. The relationship between seismic events and subsequent eruption activity on Kamchatka is well documented, though the precise causal chain remains an active area of research. Seismic tremor at Sheveluch itself remained elevated in the days leading up to the eruption, a signal that magma or pressurized fluids were moving through the system at depth. KVERT's real-time seismic network flagged the increasing tremor. NASA's FIRMS thermal detection platform recorded thermal anomalies at the summit. The system was telling anyone who was watching exactly what it intended to do. And now, scientists fear history may be repeating itself. In April of 2023, Sheveluch produced the most powerful eruption it had delivered in more than 60 years. The ash plume reached confirmed heights of approximately 20 kilometers at the peak of activity. A cloud of volcanic ash spread across an area of approximately 41,700 square miles, darkening skies across a vast swath of Kamchatka. A 500-kilometer-long ash cloud drifted northwest across the peninsula. That event prompted a red aviation warning, the highest classification, and forced emergency responses across the region. It was a sharp reminder that, despite Sheveluch's reputation for continuous moderate activity, it retains the capacity for eruptions of an entirely different order of magnitude. But to find the most chilling historical parallel, you have to go back further, to 1964. In November of 1964, Sheveluch produced a VEI-4 eruption, a volcanic explosivity index rating that classifies it as a significant subplinian event. The eruption triggered a massive debris avalanche, sending enormous volumes of rock and volcanic material cascading down the mountain's flanks. The scale of destruction to the landscape was enormous. A VEI-4 event releases energy orders of magnitude beyond what Sheveluch produced in March 2026. The current event has been classified at VEI-2, a moderate eruption by comparison. But here is the part that demands attention. The 1964 eruption did not announce itself with weeks of catastrophic warning signs visible to the naked eye. Kamchatka's volcanoes have a long record of accelerating rapidly from moderate activity to major explosive events. The transition from episodic ash emissions to dome collapse and full pyroclastic eruption can happen within hours, not weeks. And the infrastructure for detecting that transition in real time, as advanced as it has become, still cannot provide the kind of lead time that would allow for safe evacuation of nearby settlements if the escalation were rapid enough. Kliushi is the settlement most directly in Sheveluch's shadow. With a population of approximately 5,000 people, it sits roughly 50 kilometers from the summit. In geological terms, 50 kilometers is not a wide margin. Pyroclastic density currents from major eruptions have been documented traveling tens of kilometers from their source. Yet lahar flows, volcanic mud flows triggered when hot ash and pyroclastic material melts the ice and snow blanketing Sheveluch's upper slopes, can travel even further, following river valleys and gullies downslope at speeds that outpace walking and, in the most powerful events, outpace vehicles on unpaved roads. Kevert's own hazard assessment for the current eruption explicitly flags lahar potential as a high-confidence ongoing risk. The volcano is heavily snow-covered. The pyroclastic flows that swept across 5 to 7 square kilometers of the flank during this eruption deposited hot material directly onto snow and ice. If the eruption sustains or intensifies, the volume of snowmelt accelerates. Water saturates volcanic debris. The resulting mixture, dense, fast-moving, and carrying everything from boulders to fine ash, flows downhill along whatever pathway exists, because what happens next could rewrite maps. As of March 31, 2026, the orange aviation warning remained in effect. CAVIRT's bulletin noted that continued explosive activity was possible through at least April 5, 2026, meaning the system had not closed, had not exhausted its energy supply, and had not returned to baseline. Elevated seismic tremor continued. Thermal anomalies remained detectable through NASA's MODIS satellite system. The ash plume was still being tracked by the Tokyo Volcanic Ash Advisory Center as it drifted east-southeast toward the Bering Sea and the Aleutian Islands. The Kamchatka rescue teams affiliated with Emercom Russia, the Ministry of Emergency Situations, were placed on standby but had not been deployed. Medical teams were prepositioned in Petropavlovsk, Kamchatsky. Ash cleanup materials had been distributed to farms in nearby villages. The approximately 500 residents living in the smaller settlements closest to the volcano were being monitored. No evacuations had been ordered. No casualties had been reported. No structural damage to any settlement had been confirmed. On the surface, those facts read as reassuring. And in the immediate context of this specific eruption at this specific moment, they are. The VEI-2 classification reflects a moderate event. Danila Chebrov, the director of the Institute of Volcanology and Seismology's Kamchatka branch, described Sheveluch in frank terms. Sheveluch erupts constantly. It's practically never calming down. It's characterized by small episodic emissions like these, and that's it. Most often, its eruptions are short-lived. That is the expert read. And it is almost certainly accurate for this eruption cycle. But experts who study Kamchatka will also tell you something else. Something that sits beneath the reassuring language of routine monitoring bulletins. Sheveluch is not the only system active on the peninsula right now. Kamchatka hosts approximately 29 active volcanoes. The Kluchevskaya group, which includes some of the most powerful volcanoes in the world, sits within the same regional complex as Sheveluch. In April of 2023, when Sheveluch produced its most powerful eruption in over 60 years, the volcano Bezimiani, a system that had been dormant for more than 1,000 years before suddenly reactivating in 1955, also erupted within weeks of the Sheveluch event. These volcanoes share the same subduction-driven magma supply system. They respond, at some level, to the same deep geological pressures. The confluence of elevated seismic activity, ongoing dome growth, fresh pyroclastic deposition on snow-covered slopes, and unresolved tremor data means that the Sheveluch system, as of the final days of March 2026, is not a closed chapter. It is an open question. CAVIRT continues issuing hourly bulletins. The Tokyo VAAC continues tracking the ash cloud. NASA's satellite systems continue recording thermal signatures from the summit. Scientists at the Russian Academy of Sciences Far Eastern branch continue analyzing seismic waveforms, looking for the specific signatures that would indicate a shift from episodic moderate activity towards something larger. They have not found those signatures yet, but the data also has not told them the eruption is over. There is a quality to Sheveluch that makes it different from the volcanoes that dominate popular imagination, the ones with singular catastrophic events separated by long periods of silence. Sheveluch's danger is precisely its continuity. Because it never fully stops, the baseline of normal creeps upward over time. Each moderate eruption is compared not to a quiet mountain, but to the last eruption. The reference point shifts. And in that shifting baseline lies the risk of underestimating what the mountain is capable of in its less ordinary moments. The tephra layers deposited by Sheveluch over its 65,000-year history serve as geological timekeepers across the Kamchatka Peninsula. Scientists use them to date and sequence other geological events in the region, the way archaeologists use pottery shards. Each layer in the sediment record is a frozen moment, an episode of violence compressed into centimeters of dark ash. There are dozens of those layers. Some of them are thick. Some of them represent events with no modern equivalent in living memory. The layer being deposited right now in March 2026 is thin by comparison to those older, deeper records. It will become one data point in a sequence that stretches back through time in a way human lives cannot encompass. But It is also a signal in the present tense, arriving in real time, telling scientists and residents and anyone paying attention that the volcano remains alive, remains pressurized, remains capable, and the monitoring systems, not as sophisticated as they are still measuring a system that ultimately operates on its own schedule, in its own language, in the deep geological time that does not wait for forecasts. Sheveluch has been erupting in some form or another for as long as human civilization has existed on Kamchatka. It erupted before the monitoring stations were built. It erupted before the aviation corridors existed to disrupt. It will be erupting in all likelihood, as long after the current alert status has been lifted and the ash has settled back into the snow. The question that no bulletin, no satellite, and no seismic array can fully answer is not whether Sheveluch will erupt again. The question is what it will look like when it decides to remind us what it truly is. Stay safe, stay curious, and keep your eyes on the Earth.